Hello students, today we will discuss one topic, that is the addressing schemes in the IP version 4, or we can say that in today's lecture we will discuss the classful IP version 4. So basically, as we have already discussed, that an IP version 4 address is 32 bits long. It means the address space of the IP version 4 is 2 raised to power 32, and we can say that over 4 billion IP addresses can be used. So first of all, there are 5 classes addresses. So if we first discuss their names, they are class A, class B, class C, class D and class E. So out of all 5 these, we are just using the first 3 classes, that are class A, class B and class C. Why aren't we using the class D and E? There is a specific reason for that, because these classes, class D and E, are specified or reserved for the research and military purposes, right? So let us discuss the ranges of these classes first. So the class A is having the range of the IP address between 0 to 127. Class B is having the range of 128 to 191. Class C is having the range of 192 to 223. And class D is having the range of 224 to 239. Then the class E is having the range of 240 to 255. So as a whole they are 256, that is 1 to 256 or 0 to 255, right? So now let us discuss the what are these first byte, second byte, third byte and fourth byte specifying, and then we will also discuss the net IDs and host IDs, right? So here you can see that we are having some highlighted bytes over here. So 1 byte is equal to 8 bit. So if we discuss for the first one, right, we will move to this block. So here you can see that there are some of the number of blocks, there are some block size, and then their applications, right? These are all the classes. So these number of blocks, we will calculate them from the net IDs, and the block the block size, we will calculate them from the host IDs, right? So the highlighted one are the net IDs and the rest are the host IDs. So in the class A, the first we are having the first one single block as the net ID. In class B, two blocks or bytes as the net IDs, and in class C we are having the 3 bytes as the net ID, and the remaining one are host IDs. So from these net IDs we will be calculating the number of blocks or organizations, and from the remaining the host IDs we will calculate the block size of each block in every class, right? So here you can see, if we discuss the example of the first one, in the class A we are having 1 byte as the net ID and 3 bytes as the host ID. So here you can see that 0, so here the 1 bit is specified for a specific reason, right? The remaining bits are 7, so 2 raised to power 7 equal to 128, right? Now how we got this block size from these host IDs? So here we are having the 3 bytes that are specifying the uh, host IDs, right? So 1 byte is equal to 8 bits, so 8 into 3, that is 24, so 2 raised to power 24, we will get this answer, that is 16 million and 77,000, like this, right? So this is how we will calculate the number of blocks and the block size. Again, here in the class B you can see that we are having 2 bits reserved, right, and having 2 bytes representing the net IDs. So these 8 bits, 8 plus 2 bits, we will subtract the 2 from 8, 8 plus 6, 14, so 2 raised to power 14, we will get this answer 16,384, right? Now in order to calculate the block size, we are having 2 bytes representing the host IDs, so 2 raised to power 16, we will get this answer 65,536. Now in the class C we are having 3 bytes representing the net IDs, and in the first byte the 3 bits are reserved, so the remaining one are 5, so we will be having 21 bits representing the net IDs, so we can calculate the Number of blocks from this 2 raised to power 21, we will get this answer, right? That is some 20,97,152. Now in the class C, only one byte is representing the host size, which we can use to calculate the size of the block. So 2 raised to power 8 will give us the 256 answer. So here you can see that is giving us the 256 answer, right? So here you can see in the class D and E we are having only one block as they are reserved. So the size of the block will be calculated from all the bytes we are having. These are the 2 raised to power 32 or 2 raised to power 28, because we are having the 4 bits here and 4 bits here reserved, right? So this is how we can calculate the number of blocks and the number of block sizes using the net IDs and host IDs. And we have already discussed that how to identify which byte is representing the net ID and which byte is representing the host ID. So here in the class A, the first byte is representing net ID, in class B the first 2, and in the class C the first 3 are representing the net IDs and the remaining are representing the host IDs. Now we can calculate. So here are the applications. The first 3 are used for the multicasting and the remaining 2 are reserved for the special military purposes. We can also calculate the total number of IPs. So in any class or in every class, how can we calculate that? Here you can see we will subtract. We are having 4 bytes in every class, right? So in the for the first 3 classes we will subtract the reserved ones and then we will calculate the remaining bits. So in the first one, if we subtract the reserved one, that is 1, so 2 raised to power 31 will give us the total number of IPs in the class A, that how many number of IPs we can have in the class A. The same is the case for the class B, that we are having 2 reserved bits, so 4 bytes, 32 bits, 32 minus 2, 2 raised to power 30, and then we will get the total number of IPs for the class B also. Likewise, we will do the same for the class C. We are having 3 bits reserved in the class C and we are having 4 bytes, so 32 minus 3, that is 29, 2 raised to power 29, we will get the answer that how many total number of IPs we can have in the class C. So this was all about the Classful IP version 4, that is 32 bits long. We discussed the classes and how to identify the net IDs, how to identify the host IDs. So this was all about the IP version 4.